Hi students, this is Naveen from AKN Sprint Education. ఈరోజు మనం ఫిజికల్ సైన్స్ ఆల్ చాప్టర్స్ రివిజన్స్ని స్టార్ట్ చేద్దాం. బికాస్ వీ హ్యావ్ ఎగ్జామ్ టుమారో. లెట్ us రివైజ్ హోల్ చాప్టర్ ఆల్ ద చాప్టర్స్ ఇన్ యువర్ ఫిజికల్ సైన్స్. ఓకే, కమింగ్ టు చాప్టర్ నెంబర్ 1, రిఫ్లెక్షన్ ఆఫ్ లైట్ at curved surfaces. So children, in this chapter mostly they'll focus on spherical mirrors. So spherical mirrors are of two types. They are concave mirrors and convex mirrors. Sometimes they'll ask you to identify the pole, center of curvature and focus of a concave mirror. You can see the diagram: pole, focus and center of curvature, right? So they may ask identifying the pole, center of curvature and focus of a convex mirror. That is for 2 mark question. Children, see their pole, focus and center of curvature. And also you can differentiate between concave mirror and convex mirror. As here concave mirror, bent inside surface, bent in surface, this is our pole and this is focus and center of curvature. Whereas for convex mirror, you can see this is bulging out surface. Inside we have oblique lines, so ray of light will fall over convex surface. So for this, pole is here, focus is here and center of curvature is over there, right? Children, did you understand the difference between concave mirror and convex mirror? Yes. Now the point of intersection of all normals drawn from the point of incident to the mirror is known as center of curvature. What do you mean by center of curvature? The point of intersection. See, this is our point of intersection of all normal. This is incident ray, normal. Incident ray, normal. The point of intersection of all normals drawn from the point of incident to mirror is known as center of curvature. So the center of curvature can be drawn using a ray diagram. Next, focal length. Distance between pole and focus is known as focal length. So focal length will be half of the radius of curvature. What do you mean by radius of curvature? Distance between pole and center of curvature is known as radius of curvature. This is our pole. Distance between pole and center of curvature is known as radius of curvature. Distance between pole and focus is known as focal length. Okay children? And the most important relationship between focal length and radius of curvature is focal length of the mirror small f is equal to r by 2. I mean half of the radius of curvature. See here children, if focal length radius of curvature, then focal length is r by 2. The question is, the numerical is, if the radius of curvature of the mirror is 30 centimeter, and then find the focal length of the mirror. So what is given? Given radius of curvature is 30 centimeter. Now they are asking to find focal length. Focal length is nothing but half of the radius of curvature. I mean 30 by 2. 2 1 ja, 2 15 ja. So which is equal to how many centimeter? 15 centimeter. Next one, which is the most important 8 mark question. The material required to find the nature of image formed when an object is placed at different places on the principal axis of a concave mirror and experimental procedure. So this experiment is the most important experiment and also which is 8 mark question. Now you can see materials required for the experiment are concave mirror, V-stand, screen, object or candle. Also we need meter scale. The precautions you have to take: adjust the screen without disturbing the incident and reflected rays. So size of the object adjusted must be as per the height of the lens placed on V-stands. Now the procedure: place the mirror on the V-stand, place the object on the principal axis at different places from the mirror, that is beyond C, at C, between C and F, at F, between F and P. Adjust the object to get sharp image on the screen. Measure the object and image distances. Tabulate the values in the following table. Observe and mention the images are inverted or erected. Children, even though you need to draw the table. Children, this is the most important 8 mark question. Spherical mirrors ray diagrams. Rules to draw ray diagrams of formation of images by spherical mirrors. Coming to first point, both concave mirror and convex mirror, a ray of light which is parallel to the principal axis. This is the ray of light which is parallel to the principal axis. After reflection, it must passes through the focus. This is for concave mirror. As well as convex mirror, a ray of light which is parallel to the principal axis, after reflection, it appears to be coming from its focus. That is our rule number 1. Coming to rule number 2, all the rays passes through the focus of a mirror will travel parallel to the principal axis after reflection. See children, if a ray of light passing through the focus, after reflection it becomes parallel to the principal axis. Here also a ray of light which is parallel to the principal axis of a convex mirror, after reflection it becomes, if it is passing through the focus, after reflection it becomes parallel to the principal axis. Coming to rule number 3, a ray of light which is passing through the center of curvature, after reflection it does not deviate its path, again it comes back along with the same path but in opposite direction. Even though for convex mirror, a ray of light passing towards the center of curvature, after reflection it does not deviate its path, again it comes along with the same path but in opposite direction. Okay children, a ray coming from the object passing through the principal axis to meet the mirror, it will get reflected along the principal axis. See, it is coming in the same direction, again it goes in opposite direction but the same path. Now characteristics of image, concave mirror. See, characteristics of image when the object is placed beyond C. So see here, object is beyond center of curvature. This is our first ray. A ray of light which is parallel to the principal axis of a concave mirror. After reflection it must passes through the focus. Second ray of light which is passing through the focus. After reflection it becomes parallel to the principal axis. So a ray of light, when an object is placed beyond center of curvature, where we got the image? We got image in between pole and center of curvature, focus and center of curvature. So image formed between F and C, and which is a real image and which is inverted image. Okay children, so that is the characteristics of images when an object is placed beyond center of curvature when in the case of concave mirror. Now coming to second case, when an object is placed at center of curvature, which is the most important case children. If you place an object at center of curvature, image is also formed at center of curvature only. What about the size of the object? Same size as the object, which is real image and inverted image. So this is the most important case children. So this is the object, when we place an object at center of curvature, image also we got at center of curvature only. Okay children. Now coming to third case, when we place an object between focus and center of curvature, a ray of light which is parallel to the principal axis, after reflection it passing through the focus. Second ray of light passing through the focus, after reflection it becomes parallel to the principal axis. Okay, where they both met beyond the center of curvature, which is a real image, and diminished, which is inverted image. Now coming to case number 4, when we place an object at focus, where you will get the image? You will get image at infinity. And what about the characteristics of image? They do not intersect if they extended either side. So we cannot say whether they are real or virtual image, but we can say that image is enlarged and formed at infinite. Okay children. Now when we place an object between pole and focus, which is the most important case, here in this case image formed is virtual image, enlarged and erected image. When we place an object between pole and focus, you will get virtual image children. Only in this case for concave mirror you will get virtual image. Okay. And now when you place an object in front of the concave mirror, you will get erected image, diminished and virtual image is formed. Okay children. Now the most important formula, that is called mirror formula, which gives relationship between object distance, image distance and focal length. That is 1 by f equal to 1 by v plus 1 by u. Right. Next, sign convention. They may also ask for 4 more question this sign convention. See here, the first point is all distances should be measured from the pole. So children, all distances should be measured from the pole. Next, the distances measured in the direction of incident light to be taken positive, and those measured in the direction opposite to incident light are taken as negative, right? So this is the direction of light ray. It should be measured from the pole, then this will be negative. That's why object distance will be negative. Okay. Coming to third point, height of the object and height of the image are positive if we measure upwards from the principal axis, and negative if we measure from downwards. Okay. That is the three most important sign convention. Coming to magnification. Magnification is the ratio of image distance to the object distance with a negative sign. It is the ratio of image distance to the object distance with a negative sign, or also we can define as height of the image to the height of the object. And the most important 4-mark question or else 2-mark question, uses of concave mirror and uses of convex mirror. Nowadays they are asking like anything, children, this question. Dentists use the mirror to check the teeth in the microscopes, in the security systems, in the preparation of solar cooker. Those are the uses of concave mirror. Now coming to uses of convex mirror, those mirrors are used as rear view mirror in the vehicles. Convex mirrors are used as rear view mirrors in the vehicles, at junction of the roads, in the shopping malls, at curved roads. Okay, children. Now, what would happen if the concave mirrors were not discovered? Which is the most important question. If the concave mirrors were not discovered, the dentist can't check the teeth, the solar cooker could not be used, and the car headlights would be different. So that is the if we are not discovered concave mirror, we cannot check the teeth, doctor cannot check the teeth, the solar cooker could not be used, and the car headlights would be different. Then the most important question, differences between real image and virtual image. It is an inverted image, it is an erected image, it can be caught on the screen, it cannot be caught on the screen, it can be formed by using concave mirrors but not convex mirrors, it can be formed by both concave and convex mirrors, it is formed by the reflected rays, it is formed by extending lines of reflected rays. Which is the most important question, children. Next question, an object is placed at 12 cm distance from the pole of concave mirror and the image formed at 4 cm from the pole. Find the focal length of the mirror. Children, here in this case, object distance is given 4 cm and image distance is given 4 cm, and they are asking to find focal length. So we need to use mirror formula, 1 by f equal to 1 by v plus 1 by u. According to sign convention, for concave mirror, object distance will be negative and image distance will be also negative. So 1 by f equal to minus 1 by 4 plus minus 1 by 2. LCM of 4 and 12 is 12 into 3 into 3 into 1 into 1. Minus 3 minus 1 minus 4 by 12. 4 1 ja, 4 3 ja. 1 by f equal to minus 1 by 3. So focal length equal to minus 3, children. Okay. So these are the assessment questions. Very short answer questions. What would happen if spherical mirrors were not inverted? Write the uses of spherical mirrors. What happens if concave mirrors are used as a rear view mirror of vehicles? Short answer questions also they have given 8. And long answers questions from 9 to 12. Okay, children. These questions you have to read so that you can gain out of out. Okay, children. So this is our MCQs from chapter number 1. I hope you understood chapter number 1 very clearly. Now coming to chapter number 4, refraction of light at curved surfaces. Both chapter number 1 and chapter number 4 almost are similar. There we will discuss about reflection of light at curved surfaces. Here we will see refraction of light at curved surfaces. When a light ray travels from optically rarer medium to optically denser medium, it bends towards the normal. When a light ray travels from denser to rarer medium, it bends away from the normal. The light ray which travels along the normal drawn to the surface does not deviate from its path. What is curved surface formula? N2 by V minus N1 by U equal to N2 minus N1 by R. This formula can also use for plane surfaces, radius of curvature approaches to infinity. Hence 1 by R becomes 0. Now formula for plane surface, N2 by V minus N1 by U equal to 0. that is n2 by v minus n1 by u. Now lenses are of two types, convex lenses and concave lenses. You can see here double convex lens, plano convex lens, concavo convex lens, and also concave lens, double concave lens, plano concave lens, and convexo concave lens. Okay children. Now you can see symbol of lenses while drawing. Convex lens, thick at the center, thinner at the edges. See, we can draw like this. Concave lens, thin at the center, thicker at the edges, we can draw like this. Each curved surface of lens is a part of sphere. The center of the sphere, which contains the part of curved surface, is called center of curvature. You can see the diagrams here. Here, if the lens contains two curved surfaces, then their center of curvatures are C1 and C2 respectively. The distance between the center of curvature and surfaces is called radius of curvature. In this diagram, R1, R2 are radii of curvature of surface 1, surface 2 respectively. The line joining the point C1, C2 called principal axis. The midpoint of thin lens is called optic center and it is denoted by P. Okay, now what do you mean by focus or focal point? A parallel beam of light incident on convex lens converges at a point on the principal axis. The point of convergence is called focus. You can see there. Now what about for concave lens? A parallel beam of light incident on a concave lens seems to be emerged from the point on the principal axis. See, seems to be emerges from the principal axis. So this point from which ray seems to be emanate is called as focus or focal point. Okay. Now what do you mean by focal length? The distance between optic center and focus is called focal length and it is denoted by f1 and f2 respectively. You can see this is our focus. This is our focus 1, focus 2, center of curvature 1 and center of curvature 2. Okay, this is for concave lens. This is for convex lens. Again, optic center, focus 1, center of curvature 1, focus 2, center of curvature 2. And also the most important question, behavior of certain light rays when they are incident on a lens. So we have 4 behavior of light rays. First one is ray traveling to the principal axis, parallel to the principal axis, passing through the focus after refraction. Here ray traveling parallel to the principal axis seems to emanate from focus. Second one is passing through the principal axis is undeviated. Here also passing through the principal axis is also undeviated. Third one passing through the optic center is undeviated. Fourth one also ray of light passing through optic center is undeviated. All 3 points are important points only children. Now ray passing through the focus will take the path parallel to the principal axis. If it is passing through focus, it will become parallel to the principal axis. Here ray passing through focus will take path parallel to the principal axis. They are the behavior of incident rays. So here focal plane, a parallel beam of light making an angle with the principal axis on a lens, the rays converges at a point lying on the focal plane. Okay. Now rules to draw ray diagrams for images formed by lenses. Okay. Coming to rule number 1. See ray diagrams of convex lenses. When we place an object at infinity, they all form at focus. So you will get point sized image and which is a real image. Coming to second one, when we place an object beyond center of curvature, where you will get the image? You will get the image between F and C, and which is a real image, inverted and diminished. Coming to case number 3, when we place an object at center of curvature, image also formed at center of curvature only, real image, inverted and same size as the object. When we place an object between center of curvature and focus, you will get an image beyond center of curvature, that is real image, inverted image and magnified image. Now when we place an object at focus, they both become parallel to they are parallel to each other, and you'll get image at infinity. Now when we place an object between focus and optic center, you'll get virtual image, erected image, and magnified image. Object is behind the lens you'll get. Now for concave lens, when we place an object at infinity, they appears to meet at focus. Now if you place an object anywhere between center of curvature and focus, you'll get a virtual image, and also image is formed between optic center and focus. Now coming to the most important 8-mark question, the type of images and measure the object distance and image distances. Okay, this activity is also important activity, children. The material required are candle, paper, convex lens of known focal length, V-stand, scale. The precautions are align the lens and flame on the flame of the candle at same height. Ensure that you get a sharp image on the paper before measuring the object distance. Now place a V-stand and place it on a long table at the middle. Place a convex lens of known focal length on the V-stand. Imagine the principal axis of the lens. Identify F, C on both sides of the lens. Light a candle and put it far away from the lens along the principal axis. Adjust the screen which is on another side of the lens until get image on it. Measure the object distance and image distance from the lens. Record the values. Repeat the experiment with different object distances and measure the image distances. When you do not get an image on the screen, try to see the image with your eyes in the lens from the place of the screen. So these are the observations. When we place an object at infinity, image formed is focal point at focus. Characteristics of image is point sized image and real image. When we place beyond center of curvature, image you will get between F2 and C, inverted, diminished and real. At C1 you will get at C2, inverted, same size, real. Between F and C you will get image beyond center of curvature, inverted, magnified. If you place an object at center at focus, you will get image at infinity. If you place an object between F2 and F, focus and optic center, you will get image beyond focus, that is erected, magnified and virtual image. So in most of the condition, convex lens form real and virtual image. While we move the object towards the lens, image moves far away from the lens generally. In every situation, 1 by V minus 1 by U is constant. What is lens formula, children? 1 by F equal to 1 by V minus 1 by U. The difference between mirror formula and lens formula, mirror formula 1 by F equal to 1 by V plus 1 by U, but lens formula 1 by F equal to 1 by V minus 1 by U. F is focal length, V is image distance, U is object distance. So their magnification is the ratio of height of the image to the height of the object, or negative object image distance to the object distance with a negative sign over there. But here we have only positive sign. Okay. Now the question is to check whether the focal length of a lens depends on the surrounding medium or not. To check whether the focal length of lens depends on the surrounding medium or not. Materials requires convex lens of known focal length, cylindrical vessel having much greater than focal length of the lens, black stone, water, circular lens holder. Move the lens upward slowly. Observe carefully that at what distance the clarity of vision is missing through the lens. Take a cylindrical vessel having length or depth much greater than the focal length of the lens taken. Place a black stone inside the vessel at the bottom. Pour water into the vessel up to the height such that the height of the water level from the top of the stone is 4 times more than the focal length of lens. Take the lens and fix it in circular lens holder. Now dip the lens horizontally in water using holder. Set the distance between stone and lens, that is less than the focal length of the lens. Look at the stone through the lens. Increase the distance lens and stone until you don't see the stone through the lens. You can see the stone through the lens placed in water even the distance between the lens and stone is more than the focal length of the lens measured in air. So what is the result? Focal length of lens is more when it is measured in water than that of when it is measured in air. So focal length of lens depending on the surrounding medium. So convex lens behave like a diverging lens, and when it is kept in transparent medium with great reflective index than that of lenses. concave lens behave like converging lens when it is kept in a transparent medium with great refractive index than that of the lens. So what is lens maker formula? 1 by f equal to n minus 1 into 1 by r1 minus 1 by r2. Here f is focal length, n is refractive index of lens depending on surrounding medium, r1 is radius of curvature, r2 is radius of curvature of the surface of lens. Again, sign convention, all the distances should be measured from the optic center. The distances measured in the direction of incident light to be taken as positive, and those measured in the direction opposite to the incident light are taken to be negative. Height of the image is and height of the object is are positive when we place above the principal axis. If you place an image below the principal axis, they will be negative. Children, these are the important very short answer questions. You can take out screenshot so that you can study later. Why to waste time? Okay, children? Yes. These are the important questions from chapter number 1 and chapter number 4, that is reflection of light at curved surfaces and refraction of light at curved surfaces. If you read these all questions, children, more than enough, you will get easily 24 marks.